Hi students, today's class we are going to discuss the next continuation of objective pattern of structure of atom. Objective pattern of structure of atom. So here in the last class, in the part 12, we discussed 10 structure of atom objectives. So some more problems we will do in this class. So here we have taken the 11th and 12th one. So 11th, see look at here. So m value for 2pz orbital is m value for 2pz. So before going to discuss this one, so I want to tell something regarding on how to do the objectives. How to do the objectives. See here, first we have to thoroughly read the concept of the chapter. What we are doing in that chapter. The chapter we have to go the concept. Main we have to go the deep concept of that one. So we have to revise the concept very quickly, and after that we have to enter into the objectives. So concept means don't by heart. We have to read that concept and understand and memorize. That is very important. Okay. So now, and after that, if any problematic is there, so first you read the question and write what is given there, and after that you can go through what you have to calculate, and after that what formula is needed to calculate that one, and substitute that values, given values in that formula, then you will get the answer. So this is the easiest procedure to do the problems and also to do the objectives. So objectives are very important. If you know the concept only, then we can do the objectives in very easy way. So that means what I am saying is, you have to understand the concept is very important. Very important. So you have to understand the concept is very important. So next, so when you come to the next objective, say 11th question. M value for a 2pz orbital is M value for a 2pz orbital. Look at here. What is M? M means a magnetic quantum number. So M value for a 2pz orbital is. So 2pz means what? It orientates along the z-axis. Along the z-axis. So for 2pz or any pz, there are no orientations. That means for pz there are zero orientations. There are zero orientations. So azimuthal quantum number here, magnetic quantum number becomes zero. Magnetic quantum number becomes zero. So here we have to understand that pz orbital zero orientations are there. Pz orbital zero orientations are there. So for pz orbitals, 2pz, 3pz, 4pz, zero orientation. So here m value for 2pz orbital is zero. So which option is correct there? Third option is correct. So azimuthal orientations is zero. Azimuthal orientations is zero means L is zero. L is zero means automatically M also becomes zero. So L is equal to 0 for pz. So in L is equal to 0 means M depends on M is equal to minus L to plus L. M is equal to minus L to plus L. So that is equal to M is equal to 0. M is equal to 0. So for 2pz, L is equal to 0 for which one? Pz. L is equal to 0 for pz because there are zero azimuthal orientations. So L is equal to 0. That means automatically what is the M value? How can you calculate the M value by using L? Minus L to plus L. So M is equal to minus L to plus L. That is minus 0 to plus 0. That means M becomes 0. M becomes 0. So that is the 11th question. So M value for 2pz orbital is 0. Next, when you go to 12th question, see here, the correct set of quantum numbers for unpaired electron of chlorine atom is. So here we have to calculate the unpaired electron of chlorine atom. So see here. So chlorine atom, unpaired electron. That means we have to write the electronic configuration of chlorine. So chlorine atomic number is 17. So how can you write the electronic configuration? See, look at here. So electronic configuration of chlorine is 17. That means 17 electrons will come. So 1s2, 2s2, 2p6, 3s2, 3p5. 3s2, 3p5. 3s2, 3p5. Look at here. 1s2, 2s2, 2p6, 3s2, 3p5. So how many are there here? 10. 10 plus 2, 12. 12 plus 5, 17. So 17. So he asked that unpaired electron of chlorine atom. See, look at here. See, this is the S. X has maximum capacity is 2. So these are fully paired. Next, 2s. S has maximum capacity 2 only. So it is also fully paired. And P has maximum capacity 6. It is fully paired. And S has maximum capacity 2. That is fully paired. As 3s2 came. So P has maximum capacity 6. What about here? 3p5 is there. That means here it is having only 5 electrons. But how many electrons are required? 1 electron is required. So what is the maximum capacity there? 6 electrons. So look at here. If you write the p electrons like this in the orbitals, look at here. The orbital 3p5, 1, 2, 3, 4, 5. 4, 5. So this is vacant. Here it is vacant. Look at here. It is vacant. That means it is having only 1 electron. So these both are filled and it is having only 1 electron. So it is unpaired electron. Unpaired. So one orbital of last orbital of 3p having only 1 electron. That is unpaired electron. So what is the question here? The correct set of quantum numbers for unpaired electron of chlorine atom is. So for this one, what are the quantum numbers he asked? For this one, what are the quantum numbers? See, look at here. For this one, that means here we will consider this one also. So what is the n value here? NLX notation. NLX notation. Look at here. NLX notation. So it is 3p5. 3p5. So what is n value here? N is equal to 3. N is equal to 3. So it is p. P means what is the L value? L is equal to 1. So for S, L is equal to 0. For P, L is equal to 1. For D, L is equal to 2. And for F, L is equal to 4. So here it is P. That means L value is 1. And next, when you go to next quantum number, M. So how can you calculate M? Look at here. How can you calculate M? So what is the value of M here? What is the value of M? Look at here. M will lie on minus L2 plus L. M is equal to minus L2 plus L. Minus L2 plus L. So here, look at here. So here its orientations, look at here. It is one electron and also in a half spin. It is clockwise direction. It is rotating clockwise direction. So only direction is like this. Direction is like this. So here if you take M value minus L2 plus L, that means M is equal to minus 1 to plus 1. That means minus 1 plus 1 0. Minus 1 plus 1 0. So look at here. Minus 1 plus 1 and 0. So which will indicates here minus 1 and which will indicates plus 1 and which will indicates 0. Which will indicates 0. So it is a X. It is a PX. Because in the sequence order Py and it is a Pz. It is a Pz. So Pz, I told you Pz orientations. P for Pz M value becomes 0. For Pz M value becomes 0. So it is Pz. What is M value? M is equal to 0. M is equal to 0. So finally the values are N is equal to 3, L is equal to 1 and M is equal to 0. So which option is correct there? N is equal to 3, L is equal to 1 and M is equal to 0. So here third option is correct here. Third option is correct. So in this way, so we have to go through the concept and what is given, what we have to calculate, we have to write there and after that we have to find out the required value. See here, the correct set of quantum numbers for an unpaired electron of chlorine atom. Unpaired electron. So among this, which one is unpaired? This is unpaired. So it is Pz. So the M value is 0. So why it is Pz? Because in the sequence Px, Py, Pz, it will come in last. So Z P for Pz M is equal to 0. That only will go. So this is the way to calculate to do the objective pattern. So for notes, take a screenshot this one. Next 13, 14, 15. Next 13 one. So how many questions we are learning is not important. How much concept we are knowing, that is very important. Okay, next 13th question. See, 13th question. Which of the following designation is impossible? Which of the following designation, which of the following designation is impossible? Which of the following designation is impossible? So number 1, 4F. Number 2, 5G. Number 3, 2D. Number 4, 6P. Number 4, 6P. Next 14. The azimuthal quantum number of non-directional orbital is azimuthal quantum number of non-directional orbital is azimuthal quantum number of non-directional orbital is 1, 0, second one 1, and third one -1, and fourth one +1 by. Fourth one +1 by. Next chapter. The number of electrons number of electrons with the minus of spin in n is equal to 4 is 1, 32, 2, 16, 3, 8, and 4, 9. 4, 9. 4, 9. See, look at here. So these are the three questions next up. So the 13th one, which of the following designation is impossible? Which of the following designation is impossible? So among these four options, which of the option is not possible? Not possible. So look at here, 4F. So F starts with the fourth orbital only. F starts with the fourth subshell. F starts with fourth subshell. So 4F is possible. 4F is possible. Look at here. 1, see, if you see, this is the orbital, first orbital, second, third, fourth, fifth. 1, 2, 3, 4. So it is nucleus. This is fifth video. So here 1s, next 2s, 2p, next 3s, 3p, 3d, next 4s, 4p, 4d, 4f. Look at it. 1s. So in the first orbital, what is there? 1s is there. Second orbital, 2s, 2p. Third subshell, third orbit. This is orbit, not orbital. First orbit, 1s is there. Second orbit, 2s, 2p. Third orbit, 3s, 3p, 3d. Fourth orbit, 4s, 4p, 4d, 4f. What about fifth orbit? 5s, 5p, 5d, 5F and a 5G. Look at here. Here we have to understand that 1 starts with the S starts with 1, P starts with 2, D starts with 3, F starts with 4, and G starts with 5. G starts with 5. Look at here. So among this, which of the following designation is impossible? Which of the following designation is impossible? 4F. 4F is possible or not? Yes, it is possible. It is a possible, correct. Next, the 5G. 5G. Look at here. 5G is possible or not? 5G also possible. Is correct. So here we want to know which one is not correct. Which one is not correct. Next, 2D. 2D. In the second orbit, any D is there? No. Second orbit D is not possible because D starts from third orbit. D starts from third orbit. So 2D is not possible. So the question asked is here, which is not possible. So it is correct. Is it? Correct. Next, when you go to fourth option here, 6P. 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 Yes, sir. 5P is there, and also next 6P will come. Next 6P. So 6P is also correct. So these 1, 2, 4 are correct. Third one is not correct. So he asked that which of the following designation is impossible. Impossible means third option is correct here. Third option is correct. So these 4F, 5G, 6P all are possible except 2D. Except 2D. So 2D is not possible. 2D is not possible. So in this way, first we have to go through the concept. We have to go to the concept. So simply we can write there by taking the atom. By taking the atom in that center nucleus is there, surrounded by first orbit, second orbit, third orbit, fourth orbit, fifth orbit, like that. So here S starts with the first one, P starts with the second one, and D starts with the third orbit, 4 starts with F starts with fourth orbit, and G starts with the fifth orbit. So in this way, you have to go through the concept. By knowing the concept, the question is very easy to do that one. Okay. Next, that is level 13th one. So when you go to 14th one, the azimuthal quantum number of non-directional orbitals. Azimuthal quantum number. Azimuthal quantum number means which one? Azimuthal quantum number. So azimuthal quantum number means L. Azimuthal quantum number means L. So principal quantum number N. Azimuthal quantum number L. Magnetic quantum number M. Spin quantum number is S. So here we have to know the azimuthal quantum number. Azimuthal quantum number is L. So azimuthal quantum number of non-directional orbitals. Look at here. Azimuthal quantum number of non-directional. So azimuthal quantum number of non-directional orbital. Non-direction means it has no direction. It has no direction. That means it has not the positive axis. It is not having positive axis. It is not having negative axis. So which is correct here? Not having positive and not having negative means 0. 0 means here this option is correct. This option is correct. So azimuthal quantum number of non-directional orbital is 0, or we can say as a non-direction. See here, non-direction is yes. Non-direction is yes. S has no direction. S has spherical in shape, but what is the direction? No direction. So if you take P has a direction is there. P dumbbell in shape. It is lies on x-axis, y-axis, like that. So S has no direction. So azimuthal quantum number for S. For S, what is the L value? 0. For S, L value is 0. So L value is 0. That only he asked. So that is the 14th one. Next, when you go to 15th one, see, look at here. Number of electrons with the minus of spin in N is equal to 4 is. N is equal to 4. See, look at it. This is very important one. Number of electrons with the minus of spin in N is equal to 4 is. N is equal to 4. That means what? N is equal to 4 means 4th orbit. N is equal to 4 means 4th orbit. So in 4th orbit, totally how many electrons are there? In 4th orbit, totally how many electrons are there? In the total electrons, how many are having plus of and how many are having minus of spin? So here he asked only the minus of spin. He asked only the minus of spin. See, look at here. So here we wrote already 4th orbit. 4th orbit, what are their subshells? 4F, 4P, 4D and 4D. 4F, 4S, 4P, 4D and 4F. See, look at here. 4S 4s, how many electrons maximum? 2. Next 4p, 6. Next 4d, 10. Next 4f, 14 electrons. 14 electrons. So totally in the fourth orbit, totally how many electrons are there? 14 plus 10, 24. 24 plus 6, 24 plus 6, 30. 30 plus 2, 32. 30 plus 2, 32. So out of 32, see out of 32, all are completely filled. All are completely filled. Out of 32, half 16 are showing plus of spin and 16 are showing minus of spin. So here the number of electrons with the minus of spin is 16. Minus of spin is 16. Or otherwise, if you go deeply, see here, if you write here like this. So 1, 2, and P is having 3. So 1, 2, 3, 4, 5, 6. And D is having 5. 1, 2, 3, 5. See, look at here. 1, 2, 3, 4, 5, 6, 8, 9, 10. One, two, three, four, five, 6, 7. 1, 2, 3, 4, 5, 6, 7. Look at here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. See, look at here. So this it will show plus of and it will show minus of. See, this direction shows plus of and this direction shows minus of. How many this direction electrons are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. 16 electrons. So 16 electrons. So number of electrons with the minus of spin in n is equal to 4 is. So here n is equal to 4. That means fourth orbit how many electrons are there? Totally we have to calculate that one. After that, if n is equal to 3 is given, in the third orbit how many electrons are there? That one you have to calculate. After that, we have to go for minus of spin among that one, which are showing minus of spin. So here is totally 32 electrons are there. In the 32, 16 are showing minus of and 16 are showing less of. So here answer is option is 2, that is 16. That is 16. So this is the 15th question. So for notes, take a screenshot. So this concept is very, very important. This concept is very, very important. Next, next 16th one. Sixteenth one. See, look at here. Which of the following is a violation of police exclusion principle? Which of the following is violation of police exclusion principle? Which of the following is violation of police exclusion principle? See here. Options are first one. Second one. Third one. Fourth one. And next 17th one. The following species has lowest number of electrons in valence shell. The following species has lowest number of electrons in valence shell. In valence shell. See here, first one O minus 2. Second one S. Third one N minus 3. Fourth one Cl minus 1. Cl minus 1. Next 18th one. When n is equal to 3, see here, when n is equal to 3, n is equal to 1, the designation given to orbital is designation 4s, 4p, 3s, 3p. Options are 4s, 4p, 3s and 3s. See, look at here. So next questions are 16, 17 and 18. 16th question, when you look at the 16th question here, which of the following is violation of police exclusion principle? So here 4 options are given. So in these 4 options, which one is not following police exclusion principle? He asked that Which one is not following the Pauli's exclusive principle? So what is Pauli's exclusive principle first of all? See, if you look at here, Pauli's exclusive principle means no two electrons or any two electrons cannot have same set of 4 quantum numbers. Cannot have same set of 4 quantum numbers. See, the question is any two electrons cannot have same set of 4 quantum numbers. So look at it again, we will see the question, because the question so here we have to write here this one 2. Same spin. And here same. This is same. So now look at here. Which of the following is violation of Pauli's exclusive principle? So what is Pauli's exclusive principle first of all? Any two electrons, see look at it, any two electrons cannot have same set of 4 quantum numbers. Cannot have same set of 4 quantum numbers. 4 quantum numbers. Cannot have same set of 4 quantum numbers. Any two electrons cannot have same set of 4 quantum numbers. So if you take any two electrons cannot have same set of 4 quantum numbers, he said. See, if you take the first option, that means if you take any two electrons of 4 quantum numbers are not same. 4 quantum numbers are not same. So in this, if you take this one, plus of minus of, in this also plus of minus of, different are there. So that means it is wrong. This option is wrong. Next, when you go to second one, if you take these two electrons, both are having same spin. That means in the second option, look at here. In the second option, it is like this. Second option is like this. So for this, S is equal to plus of, and for this also S is equal to plus of. But what is that? Any two electrons cannot have same set of 4 quantum numbers. But here see, spin quantum number is same. It is having plus of and it is having plus of. So which option is correct there? Second option is correct. Next, when you go to third option, it is different. Here different, here same. Here also different. If you here only one is there, here one is there. What about this one? 2s. What about this one? 2s or 3s? It is S, it is P. Yes, L is equal to 0. For P, L is equal to 1. Different. But what about here? Same are there. Same. So, but according to definition, what is that? Different. It should be different. But here, same. Here, same. So, which of the following? Violation. Violation means what? Not following Pauli's exclusive principle. So, it is not following Pauli's exclusive principle. So, which is not following? Second one is not following Pauli's exclusive principle. So, which option is correct there? Second option is correct here. Second option is correct. So, here the question is for which is not following Pauli's exclusive principle. So, we have to go for the question. So, question is what? Pauli's exclusive principle. What is Pauli's exclusive principle? No, any two electrons cannot have same set of 4 quantum numbers. Cannot have same set of 4 quantum numbers. Same set does not occur. Same set. So, same set. But here same set occur. So, that means it is not following Pauli's exclusive principle. That means it is violated. It is violated the Pauli's exclusive principle. So, second option is correct. Next, when you go to 17th one, the following species has the lowest number of electrons in valence shell. So, look at here. The following species. What is the species? First one, O minus 2. O minus 2. Look at here. O minus 2. So, oxygen. What is the electron configuration? 1s2, 2s2, 2p4. 2p4 oxygen. O minus 2 means 2 electrons are added here. 2 electrons are added means 4 plus 2. That means it becomes 6. It becomes 6. It becomes 6. So 1s2, 2s2, 2p6. 1s2, 2s2, 2p6. Look at here. O minus 2 means 2p6. Next, second one. Sulfur. Sulfur is 16. Sulfur atom number is 16. 1s2, 2s2, 2p6. 3s2, look at here, 10 now, and 1s2, 2s2, 2p6, and 3s2, 3p4, 16. So look at here, 6 plus 2, 8, 8 plus 2, 10, 10 plus 6, 16. How many number? 16. This one is 8, this one is 16. Next, third one, n minus 3, nitrogen is 7, nitrogen is 7, n minus 3. So 1s2, 2s2, 2p3, 1s2, 2s2, 2p3, 7. But here 3 electrons are added. That means it becomes as 6. It becomes as 6. Next, fourth one, chlorine. Chlorine minus 1. Chlorine is 17. So see here, 1s2, 2s2, 2p6, 3s2, 3p5, 17. But here one electron is added. One electron is added. So instead of 3p5 becomes 3p6. So now the question is, the following species has the lowest number of electrons in the valence shell. In the valence shell means outermost shell. So outermost shell which is having a less number of electrons he asked. So outermost shell, which is outermost shell? This is outermost shell. For oxygen, how many electrons are there? 6, 8. How many electrons are there? 8. What about here? Valence shell, how many electrons are there in this? 6. Next, valence shell, how many electrons are there here for nitrogen? N minus 3, 8. And valence shell, how many electrons are there here? 8. So now here 8 and 6. So which is having less number of electrons in the outermost shell? Sulfur. So it is answer is this one. So in this way, so we have to read the object question and what is required, that we have to write there. From that we can know which is the correct option. Next one. So that is 17th one. So you look at here, valence shell 8 electrons, oxygen 8, O minus 2 8, sulfur 6, nitrogen N minus 3 8, and Cl minus 1 8. So which is correct there? Is sulfur, because it is having only 6. Valence shell is having 8, it is having 6, it is having 8, it is having 8. So which is having less means sulfur, it is having 6 only, 6. Next one. So when n is equal to 3, n is equal to 1, the designation given to orbital is. So n is equal to 3, n is equal to 1. Look at here. So n is equal to 3, n is equal to 1. So in the notation, nx notation, n is equal to 3, n is equal to 1 means p. N is equal to 1 means p. So now which is option? Correct option is correct. Which is correct option? Fourth one is correct. 3p. N is equal to 3 and n is equal to 1. N is equal to 1 means p. N is equal to 3 means third R. That is 3. So in this way, so we have to solve all these problems by using the concept. So note on this one. So that's all for this session. So next class we'll do some more objective pattern. So see here. So first we have to read the question. So what are there, what are required, what is given in the objective, and before that you have to go for concept perfectly. Then only we can solve the objective questions. Next we go to next section.